In this lesson, we're going to learn about graphing absolute value functions and doing translations on the coordinate planes. Let's start with a quick review of graphing, but do it with absolute value functions. We'll start with the function y equals the absolute value of x. Now, the way you start graphing is exactly the way you would start graphing any other function if you don't know what it looks like, and that is to make a table. So we're going to make a table of values of x and figure out what the values of y are. And it's a good idea to pick some negative and positive values of x to start with. So I'll pick some values of x. Then we'll figure out what y is. So if x is negative 3, the absolute value of negative 3 is 3, so y would be 3. If x is negative 2, the absolute value of negative 2 is 2. If x is negative 1, the absolute value of that is 1, and then 0, 1, 2, and 3. So we've made our table. Now we plot points. We'll start at negative 3, 3, negative 2, 2, negative 1, 1, 0, 0, 1, 2, and 3. And we see that the graph actually looks like it is V-shaped. So the graph, when we complete it, will look like that and that. So there's the graph of the absolute value, and I'll change colors so that it looks a little better. There you can see the graph more clearly. Now let's do another graph, y equals x minus 2 plus 1. Once again, we'll start with some x values, we'll figure out what the y values are, graph points, and then see what the graph looks like. And we'll do some of these computations out. So we'll start with negative 3, and we're using the function y equals the absolute value of x minus 2 plus 1. So if x is negative 3, this would be negative 3 minus 2 plus 1. Negative 3 minus 2 is negative 5 plus 1. And negative 5, absolute value, is 5, so this is 5 plus 1, and that equals 6. Now let's do x equals negative 2. If y equals negative 2, this would be absolute value of negative 2 minus 2 plus 1. Negative 2 minus 2 is negative 4. And this equals actually 4 plus 1, and that equals 5. So there's 5. And I'll fill in the rest of the table for you. Now let's plot some points. Graph isn't quite big enough, but we'll figure it out. So negative 3, negative 6, that's 1, 2, 3, 4, 5, 6, okay. And then negative 2, 5, negative 1, 4, 0, 3, 1, 2, 2, 1, and then 3, 2. And then if we were to calculate one more point, we would find that the point 4, 3 would be on the graph. So when we draw this graph, it will look like this. And we'll color that differently so that it stands out. So now we can see the general shape of the graph, and in fact, any absolute value function that you graph that has just an x, and not an x squared or an x cubed, but just an x, will be a v, and it will either be a v that opens up, like the ones you see, or with negative signs in the right place, the v could be flipped. Now we're going to switch to Geometer's Sketchpad and look at how translations work. Here is the graph y equals the absolute value of x, as you've seen before. And now we're going to look at what happens to that graph when we change this function in certain specific ways. Now the first type of change we're going to make is to add a number outside of the absolute value. So we're going to be looking at equations or functions that are y equals the absolute value of x, then plus something. And here's an example of one of them. The absolute value of x plus 2 equals y is graphed here. And you'll notice that it differs from the original one in that it moved up 2 units. Let's see if we make this equation, or this function, y equals the absolute value of x plus 3. And you'll see that it moved up yet one more unit. What if the function was y equals the absolute value of x minus 4? Well, then you'll see relative to the original one, it moved down. It was translated down. So what we see with this is when you have an absolute value function, y equals x, and then add or subtract something outside of the absolute value, it translates the function up or down. Now let's look at a different kind of translation. In this case, we're going to subtract a number inside the absolute value instead of outside. And let's see what happens. Here's the original, y equals the absolute value of x. And now we're going to see what happens to y equals the absolute value of x minus 1. Now you'll notice that here's the original function, and subtracting 1 over here moves the function 1 unit to the right. Let's see what happens if we make that number inside equal to 4. Right. Compared to the original function, y equals x minus 4 has been translated to the right 4 units. Let's see what happens if the number a is a negative number, like negative 3. So we have the function y equals x minus negative 3, or actually x plus 3 is another way of looking at it. But this translates the function to the left. So when you have something like y equals x plus 3, this moves to the left. And when you have something like y equals x minus 3, it moves the original function to the right. Now these can be combined so that you can have a function y equals x minus something plus something, and translate the original function both up or down and left or right. In this case, the x minus 2, this minus 2, translates the function 2 units to the right, and this plus 1 translates it 1 unit up. And if you look here, compared to the original, the red function, x absolute value of x minus 2 plus 1, is translated over 2 units and up 1 unit. Let's do a different one. Let's use a as 4 and b as negative 6. And now we see y equals x minus 4 plus negative 6. And in this case, the translation is 4 to the right. 1, 2, 3, 4. And 6 down. 1, 2, 3, 4, 5, 6. And that's exactly where we are. Here's some example problems in which you're asked to write functions that translate the standard y equals absolute value of x function either left, right, or up and down, or both. So to write a function that translates absolute value up 6 units, we use this form, this first one, y equals absolute value of x plus b, and the function would be y equals the absolute value of x, and to go up 6, we add 6. To go down 4 units, we would take the original function, y equals the absolute value of x, and write the following, y equals the absolute value of x minus 4. So that's a translation down 4 units. Now, let's do some left-right translations. If I wanted to go left 10 units, I would write y equals the absolute value of x minus, and we're going left, so that's negative 10. But that's also written as absolute value of x plus 10. If I wanted to go to the right 23 units, that's in a positive direction, I would write y equals the absolute value of x minus 23. Finally, if I wanted to go up 1 and left 6, I would use this third form in which we use both numbers. So start with y equals, and this is going to be x. We want to go left 6, so that's going to be x plus 6, and then up 1 plus 1. And finally, if I wanted to go down 3 and right 7, this will be y equals the absolute value of x to go right 7, that would be minus 7, and to go down 3, that would be minus 3.